Good morning, everybody. This is EMEA 2024 Annual Symposium tutorial. I'm doing the second part of the tutorial, which is about OMOP and OHDSI. And I'm going to talk a little bit about what it is, OMOP and OHDSI, and how it works, and then show you the main workhorse of OHDSI, which is called application called Atlas. Which is used to generate evidence based on data in the OMOP common data model. So let me start here. My name is Christian Reich. I am professor of the practice at Northeastern University. I've also been in OHDSI for a very long time, since its inception in 2013. Before that, I was at OMOP, the predecessor initiative, also for a few years. So I've been in this for a very long time. No conflicts of interest, any of that stuff. So, OHDSI, what is it? It is a worldwide initiative. It has over 4,000 collaborators. It's in 83 countries, all over the world, all continents except Antarctica. What does it do? What is it? What are these people? Why do these people get into this? They get into this a lot and do research together. Okay, evidence generation. So OHDSI is not just a technology play. It is not just a method development play. It actually creates research, and it does so in a very collaborative fashion. Okay. And so here you see kind of like the whole connectivity graph, and every dot is a paper, and the paper is either on methods and software, or the evidence itself, or on the standards. And you can see there's a variety of this. So what is it? It's an community. It's an open source community, which means what gets done is in the public internet can be downloaded for free with no strings attached. There are commercial vendors who are also involved in this, but the core OHDSI is open source. It's open science, so it's completely transparent what it does. Again, everything is in the internet. All the studies, all the artifacts, of course, not the data. Don't have to explain that. There's a standard. It's the OMOP common data model. But there are also other things which get standardized, which are methods and tools and approaches. And it scales. It's supposed to scale, because we know that any one institution rarely has sufficient data to answer most of the scientific questions that we are facing. And there's a big push for reproducibility, which means we have to do this in such a way that other people can reproduce, test, find out if something is wrong, and so on. Because a lot of what's going on in the real world setting, real world evidence setting, is black box. You can't see the data because they have to be protected. Can't see the code because it's not shown. OHDSI has a whole ethos to get over that and make things reproducible. There's a research network, so there are people who have data. We don't know them all. In fact, we don't know how much are in the dark zone. I always bump into people who say, oh yeah, we have data in OMOP. And I said, why are you not in the network? So 544 data sources which officially admit they are doing OMOP, and they're doing research in OMOP, and they are potentially contributing to community studies and community evidence generation. Some of them do more, some of them do less. It's open. There's nobody in the middle who kind of like decides everything and is a big boss and approves none of it. Okay. The standard everything relies on is the OMOP Common Data Model. Now in its version 5.4 has been that way for a while, for good reasons, because each time you change the standard, then all the tools and everybody has to upgrade as well. It's a lot of stress. So in the initial years, versions came at rapid succession. Now this is much more mature. And it's not a big standard. It looks more impressive than it actually is. And it's patient-centric. So everything hangs off of a patient. And the whole OMOP model is designed to capture the patient experience. So what happens to the patient? What are the conditions? What are the treatments? What are the visits, the interactions with the healthcare system? What are the procedures? What are the observations? So everything is patient-centric. And sometimes, there are use cases which are more about, the inner workings of institutions and things like this. OMOP is very rigorous in that it does patient-centric data capture and analysis. And the other thing is which the OMOP model is conspicuous of is that the content is very strictly standardized as well. And that is in contrast to some of the other models that you're also going to hear today. You have to use concepts or codes prescribed by OHDSI. So and a COVID vaccine by, let's say, Pfizer, BioNTech, has the same representation in every of these 444 data sets. Okay, and you're not allowed to deviate from that. Well, of course that happens, but that is a quality issue and not an issue of how it's supposed to be. Okay, and the reason is only a rigorous standardization of the content allows you to do true federated network research, because you have to rely on them being able to. If you're doing your own research in your own world, that is fine. You can do whatever you want there. But if you're sitting outside and write a query that will run in an institution where you don't have access, you need to make sure that these guys all adhere to the exact same rules. So OMOP is very strict on that and prescribes the way the content is represented. There's a whole lot of, if the more standards you have, the more you have to explain. Okay, there's a book of OHDSI which does that, and it goes, how the OHDSI community works, how you get started, what open science mean, the common data model, the vocabularies, which again is the content, how you get to it, and then it goes into analytics, how you actually get value out of it. Okay, the book is need for a revision for a second edition, which will happen this year, next year hopefully. But this is pretty much gives you the necessary know-how to be effective. And all of the artifacts, which are tools, software tools, statistical methods, but also the studies, are in GitHub. Okay, so OHDSI has its own little GitHub space and lots of repositories, more than 150 or something like that, repositories, which will give you the common data model, which gives vocabularies, and Atlas. We're going to look at this. Cyclops cohort method is the mainstay methodology that's used to do comparative effectiveness of intervention studies, and so on and so on, prediction. So this is where OHDSI essentially lives. And again, anybody can go in and get going. Anybody, of course, can also in and contribute and make it better. What are the evidences that OHDSI produces? There's really three kinds. There's a characterization, which means what happens to these patients over time. What kind of conditions do they have? How do they get treated? What's the outcome of this treatment? How much does it cost? Whatever question you may want to ask. Okay. Characterize, doing essentially descriptive statistics. Then there is prediction, what will happen next. And the usual standard methods and all these, there are a variety of methods which are covered that you can apply depending on what the question is and how the data are constructed. Again, it expects OMOP, the data to be in OMOP, and you can declare what it is, what patients you want to predict and for what. Okay. And then population level estimation, that's a synonym of what people just call pharmacoepidemiology or epidemiology studies, which looks into a population, compares to another population, and derives whether there's an association between something, usually a treatment or an intervention, and an outcome. Okay, so that's a statistic which will say, all patients who take the COVID vaccine will have, what's the likelihood of getting a COVID compared to those which don't take it, or compared to those which take something else, whatever it may be. Okay, so these are the types of evidence that get created. This is based on technology, of course, because you have to get the data out of the model, and then you have to do statistics. And the choices that were made, they really made, just by how things evolved. There was nobody who just sat down and said, this is how OHDSI technology should work. But they were made. And it ended up that the manipulation of the data, getting the cohorts out of the larger patient population in the databases, is the domain of SQL. Okay, and as soon as the data are in hand, R gets used in order to drive the statistics and the manipulation, and R shiny is used to display the results or make visualizations. Call that dissemination. Okay, so this is the mainstay, SQL wrapped in R, which does its own calculations. There's a little bit of SQL and Python or Java, so you can do whatever you want, really. Nobody forces you to do it this way. But in reality, most of it is R. Some people find it a good idea, some people find it not so good idea, but that's what happened, and that's what's in the GitHubs. And anybody can come up with something else and do it that way. SQL is kind of like hard to avoid because these databases are large, and the core definitions are complex, and SQL is just good at doing that. The other methods they work with flat files. Flat files are too big. It's really hard to have real-world data in flat files and then operate the flat files. The terabytes of them. Problem is with SQL is there is not one, there are many. Okay, and OHDSI solved that problem and can support all these different SQL dialects out of the box. And the way to do that is there is kind of like a little funny SQL notation that you have to write this, so which is similar to SQL Server, but there are other conventions that you have to follow. How you, for example, some people have schemas, some people don't have. Some flavors have schemas, some database systems don't have schemas. So there's a certain way to do that. It's not hard. It's still just SQL. And then the other one is there's a certain reduction in what analytical functions you can use and what you can do in the SQL. So make a convention of how you write it and make a reduction to the least common denominator between all of these SQL flavors. But then you can, and some people, and this is the problem is that the institutions, they make decisions of what technology they use. And it's not the people who do evidence generation, it's some IT guy, okay, or girl who makes this decision. And, Google sponsored them a BigQuery installation, and then they need BigQuery. So it's very hard. So we learned the hard way that we are the tail and the institutions are the dog, and with respect to what database technology they use. So we have to be compatible. Okay. So there are two RS packages called Database Connector and SQL Render. SQL Render makes the standard the SQL query compatible to whatever is installed, and Database Connector deals with the access. That's it. So just to bring it back and put it in your memory, OHDSI is a community that does open science and works in an open source fashion. There's rigorous standardization, painful sometimes. There's a very rich technology stack. And the goal is evidence generation. That's the purpose. Everything else is just the means. And it's characterization, prediction, and estimation. So now I'm going to show you a real quick atlas. And it looks like they all do, except it's very similar to what I2B2 does. If you're looking from a distance, the menus, you can look at the various data sources, could be more than one data source. Some people have like a dozen. You can search the vocabularies. You can make concept sets, also known as code lists. You can build your cohorts. You can characterize, estimate, and predict. Remember, these are the three things, except they're not in menu items next to each other. You can take the cohorts and put them in pathways, what happens one after the other. You can do incidence rates of these people in the cohorts. How often do they have? How much is what's the incidence of, I don't know, a cardiovascular event in my diabetes population, that type of things. You can look at individual patients. That has to be switched on. That's often not switched on. And administrative stuff. So just quick look into the cohorts. For example, here, not the one that I wanted. Let's say here are all the lists. So this is a public demo site. They are many, exactly 179,000 cohort definitions. Okay. So let's say here, this is from our Northeastern Master's Program, diabetes and semaglutides. The OHDSI allows you to do cohort definitions that are very complex, can be very complex, and don't have just a logical combination of criteria, but also temporal combination of criteria. So this patient essentially takes semaglutides and had diabetes, has a diabetes diagnosis. In OMOP, you also have to define the cohort exit. And there's a whole, read the book of how these cohorts work. Usually the cohort exit is implicit, but in OHDSI, they have to define that and make it explicit. So when are they no longer part of a cohort? Okay. So you have to get into the cohort, get out of the cohort. And you can then add more of these criteria. This one is a read-only one, so I can't add anything here. I can add a censoring event if I want to change this exit from the cohort. But that's really what it is. And once you have figured out your general structure, initial event, and inclusion criteria. By the way, there are only inclusion criteria in OMOP because an exclusion criteria is the same as an inclusion criteria, where the criterion itself is inverted. You have, and the criteria work that they define some event in one of the tables, and you have to, of course, do the concept sets, the code lists, in order to say these are the events that I want to see. For example, semaglutides. There is just one drug name here, semaglutide, which is a concept. This is the concept code, concept ID. The beauty here is in OMOP, you can heavily rely in code definition on the hierarchy. So every drug that contains the ingredient semaglutide is a descendant of this ingredient. Okay. And in fact, there are 169 such descendants. You can look at them, and here they are. These are the various actual drugs. Wegovy, of course, that's what people know it in public, or Ozempic, or GLP-1 agonists as a class. So these are all these GLP-1 agonists that may or may not be in the study. And some of them are, even international. There's a system called RxNorm Extension, which adds all the international drugs to the RxNorm system. So you don't have to make a long list of 169 drugs in NDC, in any of the European drug repositories, BCDM and DM plus D and whatever there is. OMOP does that all for you. All you have to say is, give me all descendants of semaglutide. And then you get them all. Same is true for the diabetes. You can do the same thing. There's also a hierarchy. So give me all the patients with diabetes mellitus and the descendants, or diabetes insipidus and the descendants, but not the ones which have diabetes mellitus in remission. Those you exclude. So this is 158. So instead of having complex list of 158 codes that you traditionally have to put together, and it's very hard to understand why something went in and when something didn't go in, here the hierarchy does it all for you. Okay, that's really all I wanted to show you today. So thanks for listening, and have fun with the rest of the tutorial.